Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range, specifically how we can find those when we are given equations, and we'll do it in 5 minutes or less. So we remember that our domain is the set of all possible independent variable values, and so typically that's going to be our x values. Our range is our set of all possible dependent variable values. Sometimes it's our y values, but even in this particular problem, we see that it's not the y, it's the f of x. I've seen it as the g of x, h of x. There's several options, right? So we're looking to identify both, and typically our domain is going to be pretty easy, right? So take a look at your domain, your x. Even though it's a negative x squared, there are no limitations on that. And so what we want to see is it restricted, and we don't see any restrictions. So your domain is going to be pretty straightforward. You can use words. You can say all real numbers, or if you want to put it in a mathematical inequality, right, you can say x is going to be greater than negative infinity and less than infinity. That kind of means the same thing. Really, anything goes. Now, the range, that's where it gets tricky. So what do we know about this? Well, we know that it's going to be a parabola, because that's what happens when you have a quadratic function, right? That is a function that has a degree of 2 or has a squared as the highest exponent there. And since it's negative, that means it's going to be downward. So we know it's going to be a downward facing parabola. And we know that we have a y-intercept there of 9. So I know it's going to look something like this. It's going to be a downward facing parabola, and it is going to be have a y-intercept of down, and that negative is what's going to cause it to look down. So now let's double check. Let's go to our calculator. We're going to go to y equals, and let's just put that in there. 9 minus x squared. And we can graph this, and we got pretty close. And if we want to find the actual coordinate, we can hit the trace. We can move all around it, but you see it automatically started for us at that vertex. So we do have a range, and we'll say y is going to be less than or equal to 9, because it's a downward facing parabola, so any y value that is less than or equal to 9 is good. Let's look at another example. So we have h of x equals, we have x squared minus 2x plus 3. So once again, let's knock out that domain, because it's going to be fairly easy. There are no restrictions. So we're going to say x is going to be greater than or equal to negative infinity, or less than or equal to, or we could just say less than. We don't really need to make an equal to infinity. Or we could just say all real numbers. Now, what do we know about our y-coordinate? Well, we know our range, right, is going to say y is, and then that's really all we know. It is going to be a parabola, and it is going to be upward facing, okay? And it's going to be around 3-ish, because that's our y-intercept, right? So our standard form is going to be ax squared plus bx plus c. So that c is going to help us with our y-intercept. But this coefficient right here that's in front of the x, that b, that is actually on an upward-facing one. It's actually going to shift it down a little bit. That negative 2 is going to shift the whole thing in a downward parabola to the left. If it were a positive 2, it would move it downward to the left. And then it's opposite if it's a downward-facing parabola. So honestly, we're going to need to plug this one in. So x squared, not plus, let's make it minus 2x plus 3. And let's see what we have here. So you notice how it shifted down a little bit. And so we get down to that very bottom, and it looks like it's right around that 2. So it's going to be greater than or equal to that 2. It was a 3, but this negative 2 shifted it down to the right.